This video is a quick introduction to the Trelliscope R package, which is part of the Tessera open source environment. If you're not familiar with Tessera, Tessera is a set of R packages that enables deep analysis of large complex data, powered by a statistical approach called divide and recombine. You can learn more about it by visiting our website at tessera.io. And just to go down, one of the components of Tessera is Trelliscope, and that's what I want to cover real quickly in this video. Trelliscope is the visualization component of Tessera, which allows you to take data, split it into subsets, and create a multi-panel display of the data. And using this, you can interact with how the panels are viewed. And this is particularly useful if you have a display where you want to break it into pieces, and those number of pieces might be much larger than you'd want to view in just a static display. So, and multi-panel display is very powerful for data large or small. What I'm going to go over quickly today is a smaller data set that is actually part of the quick start on the website. But I'm actually going to use, in the Trelliscope tutorial, which you will find a link to on the, either you can get to it through this webpage or on the blog post that this video will be posted with. In the Trelliscope documentation, we actually go through the quick start in a little bit more detail. So there's a little more narrative. So I'm going to go through this. So I'm going to switch over here to RStudio where I have this document up. Now if you want to use Trelliscope, there's two packages that you need installed. Both of them are available through GitHub. One is DataDR and the other is Trelliscope. So I already have these installed, but if you have not installed them, then you can run these 3 lines to get those packages. Once we get that, then we're also going to install a package called housing data. I'll actually go ahead and install this one. And housing data has a few data sets. The main one is a set of data that has the median list and sold prices of homes in the United States from 2008 to 2014 by county and by month. So for example, and it's called housing. Oh, I actually have to load the package, of course. So you can see what the data looks like. There's about 225,000 observations. I have the county and state, the date, and the price per square foot for list and sold. I guess I should have just been running by the script over here. So if you've got all the packages loaded or installed, you need to load all of them. And then we've already looked at the housing data here. So the first step you want to do in making a Trelliscope display is set up what we call a visualization database. A visualization database is basically a place to store and organize all the visual artifacts you might create over the course of an analysis. So I'm going to, this line is not in the quick start. I'm going to work in a temporary directory. Your visualization database consists of files stored on your disk. So wherever you set your temporary, or wherever you set your working directory to be, or you can provide a full path to your VDB connection, but I call VDB con, and I give it a name. I'm calling it Quick Start, and it asks if I want to create this directory. I will say yes. Okay. And just a quick word on what connection looks like. It basically is just an object that points to where our visualization database will go. And you can see that it created some files there. My displays are actually going to go in that displays subdirectory, which is empty right now. Okay, so we're going to make one display here, and it's going to be pretty straightforward. What we want to try is splitting up the data by county and state, and then making a simple time series plot of the price per square foot over time. So whenever I'm creating a Trelliscope display, I first need to split data up into pieces, and I can do that using the divide function, which comes with the DataDR package. It's worthwhile to go look at the DataDR tutorial to learn more about how you can manipulate and get data into the format that you'd like. In our case, what we're doing is going to be pretty straightforward, just splitting up the data by a couple of variables here. So what I get is an object called by county, and if I look at that, it tells me this is a distributed data frame that's sitting in memory. An important thing, I guess, to point out here is if you learn more about DataDR, I could be working with a large data set on Hadoop or stored on the disk of my machine that might be bigger than what would fit in memory. So this is a scalable visualization system. In this example, we're just looking at something small. But I can see that I have about close to 2,900 subsets, and I can see other information about the data. These distributed data structures are stored as key value pairs. And so, for example, if I look at the first element of by county, it's a key value pair of the first county in the data set. Abbeville County in South Carolina is the key, and the value is the corresponding data for that. There's a lot more to learn about DataDR than what we'll cover. But once I have a distributed data set, basically what I need for a Trelliscope display is a function specifying what to plot for each subset, and then another function specifying some metrics that might tell me something interesting about each subset. So I'm going to create a simple panel function which takes a single argument, and it's expected that argument is any value of a key value pair. So this data frame for this county would be passed into this function. You can use any R plotting commands in your panel function, whether it's base R or lattice or ggplot or ggviz or rcharts. Some of those are more experimentally supported than others, but I'm going to use a simple lattice plot here. And I'm going to test this out on a subset on the 20th value in my data set. And you can see what I'm plotting is both the list and sold price over time. I'm just testing this on one subset to make sure it's good. The next thing we want to do, which is optional but makes the interaction much more useful, is create a cognostics function. cognostics, a cognostic is basically a fancy term for a metric about a subset of my data that I think is interesting. And I've got a few of them here. For example, I'm computing the slope of a fitted line of the list price versus time. I'm calculating the mean list price, the mean sold price, the number of observations, and I'm also computing a link to the county on Zillow, which is also an interesting thing to do. And you'll see how these become useful when we look at the viewer. So I've made a cognostics function. I can now test it on a subset to make sure it's supposed to return a named list of metrics. And so for the first subset, I get my slope, my mean list price, my mean sold price. There were not any non-NA values there, a number of observations, and a link. So once I have those, I can send these to a function called makeDisplay, where I basically give it my data object, a name and a description, my panel and cognostics function, and a width and a height, which basically specify the aspect ratio I want my panels to have. And I also can have it compute scales to make sure that scales stay the same across panels. So I run this, and right now it's just using a single core. If I were running against data on Hadoop, I would issue the exact same commands, and it would go and operate in the same way. Now that I have this, I can type view, and what this will do, my resolution is not quite right here, but what this will do is bring up the Trelliscope viewer, which gives me a list of all the displays I've created, and in this case I've only created this one. So I can click on it, and it will bring up the first panel, and you can see that I have 2,800 panels here that I can start paging through with my arrow keys, or I can click on these buttons. And so this is maybe interesting, maybe not. It's we can start looking through and getting a feel for what home prices look like in different places. But multi-panel displays are particularly useful when I can make comparisons across different panels. So I can make a bunch of these show up so I can make comparisons across. But other things I can do, I have these controls here for cognostics, and I've computed all of these metrics about each subset. They can now be used to help me sort and filter the panels in ways that might be meaningful to me. So for example, I may want to start out and say, I want to sort things from with low to high slope. I basically want to see counties that had the biggest decrease over time, moving toward increase. What you can see is I'm getting some panels where I am missing a lot of observations in the past. For example, here, I may want to filter those out. So I can go in here, and I have this number of observations cognostic. I can specify a range for it. I have a histogram here to guide me. But I also have visual filters for my variables, where I can click on number of observations, for example, and this is a quantile plot. I can also switch to a histogram, and I can say I want at least panels that have at least this many observations. I can hit apply, and now I've gotten rid of those cases with not very many observations. So now I can start to see things like Pitkin County in Colorado has had the biggest decrease in slope. A lot of these, the slopes are higher magnitude because the prices are higher. But an interesting thing I can do, I've created a cognostic that's a link to Zillow, and I can choose any of these cognostics to add as panel labels underneath my panels. So I now have a Zillow href for all of these. And so if I'm looking at one of these, and Hyde County, for example, is interesting since 2009, it had very high median prices, and then it's been pretty level at a much lower level. Maybe I want to look and see what houses are like there on Zillow right now. So that link takes me here, and I can look at homes for sale. There's one for $68,000. But this is one interesting way to look at the data. I can also, as I look through, I might want to look in increments because I'm not going to be able to look at all of them. So maybe I want to jump by 25 pages. And so I'm still looking at things with decreasing slopes. There's a lot of things within, that have gone down and rebounded. Just even looking through, a lot of these can start to help give us a feel for what's going on and where there might be data quality issues or things to look into. But I can move toward the end, go to page 240 here, and I can, I'm starting to get to the increasing slopes, and I can see places whose home values have gone up a lot. So San Francisco County, DC, prices in San Francisco have gone up from $550, $600 a square foot up to around $800. My current state of what I'm looking at is represented down here. I'm filtering on number of observations, and I'm sorting by slope. If I want to go back to not sorting by slope, I can just X that out. So hopefully that gives a little bit of a feel for what you can do with this. You can imagine if you have tens of thousands or hundreds of thousands of panels, you might want to look at them, and you might want to be able to look at your data in detail, but you're never going to look at 10,000 plots. But you can use the Trelliscope viewer to try to bring things to your attention that might be interesting. Another interesting thing. So I'm going to go back to one row and 3 columns so that we can see things a little bit better. There's also a bivariate filter where I might want to look at how pairs of cognostics behave together. So I might look at my mean list price and my mean sold price, and I'd expect there to be a nice correlation there, but I have some outliers where my mean list price was lower than the mean sold price. I can filter down to just those 3, and the reason for those becomes obvious. I have sold prices that are, these ones just have 1 point, but this one has a bunch that quite interestingly jump up for a few years. So that's how Trelliscope works. One thing that's not in the quick start that I'm going to show, because this makes sharing things with others really nice, is it's actually very easy to sync a collection of Trelliscope displays. In this case, I've only made one, but typically you'll make a lot of different views of data looking at different aspects. But I can sync this to shinyapps.io. And to go over that, there will be some detail on this in the blog post, but basically, the first thing you need to do, if you don't have an account on shinyapps.io, then you need to get one. And then there's a getting started guide for Shiny Apps. And if you go here, what you need to do is install the Shiny Apps package, and then you need to jump down to configuring Shiny Apps. And you need to go into R and set your Shiny Apps account info, which this talks about how to get that. Once you've got that, there's a function in Trelliscope that is just deploy to Shiny Apps. And if you've set up a VDB connection, that is saved in R's options, global options. So all the functions, the idea is that when you make a VDB connection, that's something that you want to persist during your entire session, because typically a visualization database is something that you make for a project that you're working on. So deploy to Shiny Apps will find your VDB connection and do everything for you to deploy the application. So here I've actually already deployed this, and it's asking if I want to update it. So I'm going to say yes. And this will work for a minute, and when it's done, it will pop up the application on Shiny Apps. Well, that's running. I guess, let's see how fast it goes. Well, I hope that from this example you've been able to get a better feel for what you can do with Trelliscope and how it can be used. Maybe you've gotten some inspiration for something you'd like to try with your data. Just keep in mind, this is best for multi-aspect data that you might want to break into more pieces than you could look at all at once. So if you want to give this a try, just go through the quick start, give this a shot for yourself, and we'd love to hear about any interesting displays you create. And if you push them to shinyapps.io, please let us know. We'd love to see them. And I think this should be finishing up here pretty quickly. If not, I will close the video and... Oh, no, here it goes. So I'm now here at hyphen.shinyapps.io/quickstart. And here it is to share with anybody, which is actually another nice aspect of this. It's a nice way to share displays with other people. It's you don't have to design a custom app as long as you are fine with and can conform to the multi-panel display idea. But you can share it with other people and domain experts who might not know a lot about programming in R or making visualizations. They can still interact with the data and help you in your statistical modeling process. So anyways, Thanks for watching.